Okay, so week 11 in this current semester, the fall 2024 semester. There's a couple things I want to go over, give you an overview of the week. So this week I have now gone through everyone that submitted their step one in the decision making process, and some people who have actually gone on to two. So I have a little bit more context for this current semester that I want to talk about. So it's really, I think, in the world we live in, and I tried to put this in the best way I could, is that if you use code that's inspired or found or outside of the course content, and all three are important, right? And make sure you do the following. First, demonstrate that the code, demonstrate with code comments you understand the code. Because anytime you submit something, right, you need to first understand it, right? Give a link to the source, right? Because it's not that it's uncommon to find code out there. This course is intended, though, for you to write code, right? With having a bit of experience as we've had. And I get that for that step one in the decision process created a certain amount of challenge based on where you came into the course. Like I had a couple of folks give me functions, and I'm like, no, I don't want functions here. I really just want you to focus on the variables and the conditional using the operators. Because I really want you to hone in on that part. Okay, so, and then there were some people, we had an ongoing discussion about the code that they submitted and where it came from. And it's not that it's, again, not uncommon to go find something you would get inspired by and maybe modify it. But even in that case, you would want to give a reference because it wasn't completely out of your own thought process. And remember, that's what you really want to have. But I get it too. So if if you find that happening, and now from step 3 on, we're basically re-implementing what we've already implemented. And in that case, right, or, maybe something before in step 1 and 2, if you use something outside of the course, right, then use your README to make a case for why your specific project, that JavaScript is a better choice, right? Like if I saw a couple of people use a ternary operator. Now, if you don't know what that is, we actually talk about that a little bit later. But you'd have to make a case for me about why use it. Because honestly, I totally get that it's fun. It's quicker than writing an if-else. But it's also not as readable. Like if it's just that I wanted to write it that way, I would say still write an if-else. If and an else-if. Okay, so just know that if and here's the deal, is I'm also going to ask you, right? This is very common. So, okay, so just know those things going forward. And again, I kind of, as I see more submissions, I can kind of give that feedback. Okay, so this week, we're going to learn something that if you've taken Java, and by the way, JavaScript, two different things. Okay, so when programmers who program in coders who code in JavaScript hear people call it Java, the back of our head, the hairs stick up. And it's only because we're so wedded to that language, which we really shouldn't be, but whatever. But in the case of what you're going to learn this week, you're going to learn object-oriented programming using JavaScript. And some people think, no, JavaScript doesn't do OOP. Well, it does. And if you don't even know what that OOP reference, don't worry about it. Okay, you're going to learn it this week. But I thought so first you're going to do is we're going to go through an exercise, a code long to learn about that. And then your the code discussion this week is actually for you to take what we've learned, because you're going to implement a class. So a class is the fundamental idea in a object-oriented programming language. Again, harping back to Java. If you were taking Java programming language, pretty much everything you do is built in some kind of class. But for JavaScript, it's not until you get to that part that you start thinking about how to implement it. So I thought I'd come over to chat today and go ask it about, because what we've written, what we've used as a data structure is an object literal. Okay. So when you code in this way, now we even saw this, you can create functions inside of these object literals. We've been using object literals as holding our input and our decision data, or in this case for the carbon footprint, the inputs and the scores, right, for that submission so that we can then have multiples and render it back. So we were saving, and this is the term, an object literal, right? So literal just object, okay? And in this case, you can still, it looks like what you're going to see when we get to object-oriented programming, right? But when we're doing OOP, when we're writing in that style, right, it's defining a blueprint for multiple objects we'd want to create. What happens here is, if for any level of complexity, if we had a lot of these objects that we had created in a literal sense, it would create much more challenge to both also from the programming environment, how much memory it takes, which is not something we really have to think about in JavaScript, but it does make it harder. But object-oriented programming is just, once you get the idea that this is a blueprint that you can then have, instead of, because in the literal sense here, every one of these objects would have to have its own function. But if we were writing OOP style creating object creations with that built-in functionality of functions, then we really can do what's called inheritance, so that we can then not have to repeat that code. So it's more maintainable, it's more efficient, more extendable. Okay, so you're learning that this week. And then what you'll end up doing is I'll have you create a class for how we could implement it into our carbon footprint. And then part of what you will do is actually then implement the evaluate food choice, the next logical one in that list of where we originally started, right? We've only done, what, 2 or 3 of the inputs so far. So we're adding to that. So not only do you have to understand the structure of how the OOP, in this case our class for the carbon footprint, but also how to add to that, and also how to modify our code base, right? So that we accommodate that new input. So we have to add to the form. We have to add to what we're saving in the object. We have to add to what we're rendering, right? So all these things now, and this is an important part, right, of what we need to do, is be able to now take new requirements and integrate that. Now, the thing I'm going to say about the code discussions is that it's really important, and I've seen most people do this, where you take it, you try it, you try it on your own, and then of course I give you the solution after you've submitted. And it's really important that if you want all the points, you come back and you actually make a note of what you learned from, like, here's what I tried, here's what I learned from watching the solution. Okay, and then so anyway, is it easy? You know, it's hard for me to say. Is it easy? But it is good to know. And spending the time to understand it, it will help you in the following ways. When you get to this place in your development for your decision, because for your decision code, we will get to the point where you will implement a class for that. So having that experience will help you when you get to a future assignment for that one. And oh yeah, just understanding the concept. And then for our decision app, we're kind of at a little bit of an awkward spot for this week. And because what you'll do is you'll have those functions, you'll be calling it many times. You'll need to make sure you implement this array of objects, right? Again, this should sound familiar because that's what we've been doing in the carbon footprint. But then you'll also be creating the form and the inputs that you'll have there. So I've given you a little bit of, like, you know, you can decide how much you want to connect all that together. But if you have at least the array of objects outputting to the console, and you are capturing the inputs from the form. And next week we will connect all that up together, but this week they're separate, so it can create a little bit of a, like, what do I do here? And you can kind of do this based on how well you feel comfortable with these concepts, but I do have a short video to help you with that. So we're at week 11. Semester is clicking by really quick. I thank you very much. I've really been enjoying interacting with students about the code they're submitting. So thanks, and I'll talk to you soon. Oh, as your reply, let's see if you hung out this long, right? I want to hear from you, like, any feedback on the beginnings of what I talked about today with this concept, right? With this inspired or found or outside the course. So anything about that. Now, if you don't have anything about that, you can ask a question about anything I've covered, but you have to have something. You can't just say no questions and, you know, it's like, it's not the point. I get why it's quick though. All right. See you later.